All right, Algebra 1, Lesson 117. This one is on direct and inverse variation squared. Now, I taught in Lesson 113 about direct and inverse variation, but it was not squared. So if you need to review that, even go back and look at your notes, look at that real quick before we start this one. Okay, so I'm going to kind of show you some direct and inverse variation statements. Now remember, when you hear weight, it's going to be a W. When you hear distance, it's going to be a D. When you hear something that says varies inversely, anytime we talk about something varying or directly proportional, you're going to use this letter K, and they always italicize it. Okay, let me see if there's any more. V is velocity, P is price, and let's see if there's any more. Strength of a field is S, and they even do radius is an R. Okay, so they're just using first letters to kind of go through, except for this one, and we're going to talk about what that means in the problems. Okay, so listen to this one. Let's do this, I'll do the second statement. The distance, and you just do it in order, the distance required to stop is directly proportional. When you hear that directly proportional, is your K. Okay, so the distance required to stop is directly proportional, remember that means K, directly proportional to the square of the velocity. Velocity squared, the square of the velocity. Okay? So all you did is just write it. Now, if you hear inverse, then it's going to be divided. So if you hear inverse, then you're going to divide. And if you don't hear inverse and it just says directly, let's put direct, you're going to multiply. So that's what I did here since it said directly. So listen to this one. The distance required to stop is directly proportional, that's directly proportional, to the square of the velocity. And they did not say inverse, they just said directly. So I'm going to multiply those two. Okay, that's one of them. Listen to this statement. Here's another multiply one. The price of a diamond, varies directly, K, remember that varies directly, as the square of its weight, the weight squared. Okay, so we're just learning how to write equations using the information they tell us. All right, here's, we're going to do two division ones. Listen to this. The weight of the body varies inversely. Okay, and when you hear that varies inversely, you're going to put a K, and then you know that it's going to be divided when you hear varies inversely. So varies, K is the number or the letter that we're using that varies, it changes. K varies inversely with the square of the distance. So the distance squared. All right, let's try one more. The strength of the field is inversely proportional. Inversely proportional, inverse means you're dividing, so we're going to put a K and we're going to divide. That's what's they'll either use directly or varies inversely, and we're using the inversely. And so it says is inversely proportional, so we're using that, to the cube of the radius. So the radius, and I hope you heard that, cube. So it'll be cubed right here instead of squared. Okay? All right, so that's just an idea of how we do things. And I'm going to leave this little portion right here, up here, so that we remember what to do. Okay, so here we go. The distance required for an automobile stop is directly proportional. Directly, so I'm going to use a K. Directly proportional to the square of its velocity. So velocity squared. If the car can stop in 200 meters, so 200 meters is distance, okay? 200 meters at 20 kilometers per hour, that's our velocity, 20 and see the squared. Then I'm going to bring my k down and equals. So we're trying to figure out what is our k, what is varying, what is the varying number. Okay, so here we go. 20 times 2, or I'm sorry, 20 times 20, yeah, is 400. Okay, 400k equals 200. All right, and remember, you're trying to answer for k, so this times 400, when we move it across the equal sign, it becomes divided by 400. So k equals 2/4, which is 1/2. K equals 1/2. All right, so that's just the first step in the problem. Because then after it says, if a car will stop at 200 meters at 20 kilometers per hour, then it says this. What will be the required stopping distance at 28 kilometers per hour? So the first part of the question, if a car can stop in 200 meters at 20 kilometers per hour, is this step 1. Step 2 is what we're going to do next. What will be required, what will be the required stopping distance at 28 kilometers per hour? So step 2, you're going to use your same thing, d equals kv squared. And because we know our k now is 1/2, so instead of putting 1/2, I'm going to put 0.5 for that k. Okay? And now we're going to enter in the information on the second part of the sentence. What will be the required stopping distance, so we're wanting to know d, distance, if at 28 kilometers per hour, that's our velocity, 28 kilometers per hour. So, here's what you do. You say 28 times 28 times 0.5, and the distance is going to equal 392. And because we were talking about 200 meters for the distance, we know that the distance also is in meters. Okay? So 392 is the distance on that one. All right, let's do a few more of these problems so you can get it. Make sure you're understanding it. All right, the distance of a body falls, the distance of a body falls varies directly. Okay, so there's that varies directly, put a k. And it's not inverse, it's direct, so we're going to multiply it by something. Varies directly as the square of the time that it falls. So I'm going to put time squared. Alright, so t is a new letter. T is for time. Alright, so here we go. Now here's what it says. If it falls 144 feet, that's the distance, and this one's in feet. 144 feet. In 3 seconds, that's our time. So we don't know our k, but our time is 3 seconds. Okay? Then, and we'll figure out the rest. How far will it fall in 10 seconds? And we'll talk about that in a minute. So right now, we're trying to figure out what it is when it's 3 seconds, and then we can determine what it will be in 10 seconds. Okay, so 3 times 3 is 9. 9 times k equals 144. And then times 9 will come across and divide by 9. K equals 16. Alright? Remember, that's just the first step. Now we've got to do the 10 seconds. So if it falls at 144 feet in 3 seconds, how far will it fall in 10 seconds? So again, you take your same thing right here. Alright? And it says, how far will it fall? Distance, how far? Okay? We know our k is 16, and our time is 10 seconds this time. So 10 squared is 10 times 10, which is 100. 100 times 16 is 1600. And the distance is in feet, so we put feet. Okay? Hopefully this is making sense. Let's do one more inverse. That way you're making sure you're understanding the inverse ones. Alright, so here we go. The weight of the body on or above the surface of the earth varies inversely. That means we do k on the top divided by. That varies inversely. With the square of the distance from the body of the center of the earth. Square of the distance. Now, if the body weighs 10,000 pounds, And remember, that's what we're trying to find is K. At a distance of 5,000 miles, 5,000 miles, remember, squared, from the center of the earth, then it says, how much would it weigh 50,000 miles from the center of the earth? That's our second part of the problem. So we'll do the first part first, because we're trying to figure out what K is. Okay, when I see, like this, divided by 5,000 squared, okay, I always like to write it out like this, divided by 5,000 squared, okay? Just makes it a little bit easier. All right, and then 5,000 squared, oh wait, I don't have to do the math of it. 5,000 squared, let's see, that's probably going to be, I don't know, 25, and then 2, 3, 4, 5, 6. All right, so that's what that equals, all right? And since it's divided by that, we're going to move this across the equal sign, which is this. And so then it's going to be times 25 million, okay? And when we get that, K is going to equal, let's see, and they go on and make this into scientific notation. So 25 times 10 to the 10th power. Now you notice this is scientific notation, but it's not written correctly. The dot should go here, but it doesn't matter because we're not actually trying to figure out final scientific notation. We're just trying to figure out what this number is. And if you wanted to write it all the way out, it would be 25 and then 10 zeros. So you could also see it like that. That's what K equals. All right, so that's the first step. I'm going to move this for just a minute. All right, now I'm going to write this, our second step, and our K, I'm going to want to use what they have, times 10 to the 10th power over D squared. Okay, so now listen to the problem. That's how we figured out our K, in which I put right here for a K. Okay, and so then what it says, let me read the second part of it. So if the body weighs 10,000 pounds at a distance of 5,000 miles from the center of the earth, how much would it weigh 50,000 miles distance, 50,000 squared? Okay, so they're asking how much would it weigh? We're looking for the W, okay? And 50,000 times 50,000 is end up being, they just went on and did this. 50,000 times 50,000 is 25 times 10 to the 8th power, okay? And so then 25 times 10 to the 10th power divided by 25 times 10 to the 8th power, W is going to equal 100 pounds, okay? And we know that it's pounds because up here is pounds. So our weight is 100 pounds. You can put that into a calculator, or you could write 25 and 10 zeros, and then 25 and 8 zeros, and divide those two. And you'll still get the same answer, okay? That is lesson 117.